Here we go with section 4.3 review. And before we go anywhere, I want to review this relationship between the log expression and the exponential expression. Log base a of x is the same as a to the y equals x. So this log function, it's not log base a times x, it's log base a of x. It's like f of x. This is a function notation. So you have to remember there's three quantities: the base of the exponential, the base of the log, and the exponent on the base, which is equal to the log. So the log equals that exponent. So let's try this with the following. Rewrite base 5 log of 10 equal x in exponential form. Here our base is 5 and the log itself equals x. So pause the tape and try this on your own. So since the base of the log is 5, that's the base of the exponential. And it's 5 to the x power, because the log equals x, equals 10, the third quantity. There's three quantities here. If you get two of them in the correct place, that only leaves one place for the third quantity. So you get two of these in the right spot, the third one automatically falls in place. Okay, so let's try the next problem. Rewrite e to the x equals 10 in log form. So same procedure, except we're going the opposite way now. We're going from exponential to log. This is sort of like number 6 of the homework. So our base is e and the exponent is x. So try this on your own. So plugging in the base and the exponent, we get log base e of 10 equals x. Well, when it's log base e, that's the special natural log, which is the same as ln of 10 equals x. So log base e, it means the same as ln. Now we can actually use a calculator to find this value. On our calculator, take ln of 10, and if you have a scientific calculator, it is going to have an ln key, and we get 2.303 rounded off. So by rewriting it in log form, we're actually able to solve this equation, e to the x equal 10. So the logs allow us to solve exponential equations. E to the 2.303 power is approximately equal to 10. Okay, in the next problem, rewrite 10 to the 4x equals 40, and then use your calculator to find x after you rewrite it in log form. So rewrite 10 to the 4x equals 40 in log form, then find x. So here our base is 10. So try this and then use your calculator and see if you can solve this for x. So rewriting this, it's a base 10 log because it was a base 10 exponential. It's base 10 log of 40 equals 4x. It has to equal 4x because 4x is the exponent. Logs will equal the exponent from the exponential. But this is a base 10 log. Now, if the base is 10, oftentimes we leave the base off. So you'll see just log log of something, that means it's a base 10 log. Now we have a base 10 log key on your calculator. If you have the ln key, you also have the base 10 log key. Log of 40 on your calculator is equal to about 1.602 rounded to 3 places equals 4x. So we take 1.602, divide by 4, and we get about 0.4005, or about 0.401, rounded off. Okay, here's 3 more problems. Rewrite the following 3 in exponential form. We have log base 3 of 7 equals x, ln, or natural log of x, equal 3, and log of x equals 2. Then remember, ln means base e log, and log, log with nothing, means base 10 log. So rewrite all 3 of these in exponential form. Okay, so in the first one, base 3, so it's 3 to the x, because the log equals x, the exponent, and that equals, well, the third quantity here is 7. So it's 3 to the x equals 7. In the second problem, it's base e to the third power equals x, or e to the third power, which we could actually find on the calculator. And the third problem, since it's log with nothing indicated, it's automatically base 10 log. So it's 10 to the 2 power equals x, which is 100. Okay, our next problem is kind of like number 3 of the homework and some of the web assigned problems. Evaluate base a log of 16 without a calculator. Now, most calculators you have won't even have a base a log key, so that wouldn't even do you much good. But I suppose you could, there are calculators where you can do base 8 logs, like some graphing calculators. But we want to do it without a calculator. How in the world do we do that? Well, you start by letting that log equal x. So we let that base 8 log 16 equals x. And in number 3 of the homework, I actually do that for you. I write it out as the log equaling x. Now, the trick, how do we find that exponent on 8 that equals 16? Well, you start by rewriting it in exponential form. The exponential form is 8 raised to the, it's got to be x, that's the exponent, equals 16. And you're probably thinking, oh, what in the world power of 8 is 16? 8 squared is not 16, it's 64. 8 to the first is just 8. Well, the trick here is to write both sides of this as a power of the same number. 8 is 2 cubed. So we have 2 cubed raised to the x. 16 is 2 to the 4th. Now, when we raise the power 2 cubed to the x, we multiply exponents. So what we really have here is 2 to the 3x equals 2 to the 4th. Now, if 2 to the 3x equals 2 to the 4th, 3x has to equal 4, right? If this is going to be equal. So we get from this that 3x equals 4. So x is 4/3. But since our log equals x, our log also equals 4/3. So this is like number 3 of the homework. Okay, number 4 of the homework seems like kind of a tricky problem, but actually it's not. And here's one similar to it. If ln of e to the 5th equals 5x, what is x? And in the homework I actually tell you, rewrite it in exponential form. Well, ln is base e. So it's e to the, well, the exponent is 5x. E to the 5x equals, and the third quantity here is e to the 5th. So e to the 5x equals e to the 5th. Well, if e to the 5x equals e to the 5th, then 5x has to equal 5. So x is 1. So that's our answer, x equal 1. Okay, you had a problem number 9 in homework that talks about graphing logs, and it's also in the notes I cover this, how to graph a log function, particularly if the log function is not base 10 or base e. If it's a base 10 log function, you can just use your calculator to find values of y, just plugging in x values and getting solution points. The same thing if it's an ln of x, which is base e of log of x, you can use your ln key. But here, this is a base 4 log. So how in the world do we sketch the graph? Well, first of all, we can write this as y equals base 4 log of x. Now, if we can just switch that around, what's the exponential form? Well, the exponential form is 4 base 4 to the y power equals x. Now, we can find solution points if we just pick the y value first. So pick the y value first and find some solution points. Y equals 0, at y equal 1, y equal negative 1. I guess we could even go y equal 2. So why don't you find those solution points, draw your curve through the graph. Try this on your own, pause the video, complete this graph, and see what you come up with. Okay, so we plug y equals 0 in. 4 to the 0 power is 1. Anything to the 0 power is 1. So x is 1 when y is 0. When y is 1, 4 to the 1 is 4. When y is negative 1, 4 to the negative 1 is 1 over 4 to the 1, which is 1/4. And when y is 2, x is 4 squared, 16. So we plot those points, 1, 0, 4, 1, 1/4, negative 1, just down there, 16, 2. Now if I just connect up those points with smooth curves, we see the graph doing something like that. Do we ever get an x value of 0? Is there any y that will give you 0? Well, even the negative y's give us positive x values. So the graph never hits the y-axis. It gets close to it, but it never hits it. So there's actually a vertical asymptote. That's the y-axis. And off to the right, the graph just continues on. It doesn't have any horizontal asymptote, but it takes a while for the graph to increase because it's a logarithmic function. But there is no limit to how big the y value can be. You just need a big enough x value. So no horizontal asymptote, but there is a vertical limit or asymptote to this function. And that's it for the 4.3 review. If you have questions, you can post them in discussions.